I'm trying to kind of educate the people that yes, text embeddings are really awesome at what they do, but they're not meant to solve everything. And there are other solutions for other types of problems, which I'm trying to enlighten people.
Hello, everybody. Welcome to another GraphGeeks in discussion. This week we have Tomaz Bratanic, who is someone I've known for many years, and he's a prolific creator of graph and graph data science content. I actually have known him for several years, did some work together on graph algorithms as well. So welcome, Tomaz. We're very excited to have you. And something that we're going to talk about today is GraphRAG, and in particular, the new book that Tomaz has written along with Oskar Hane called Essential GraphRAG. So we'll be talking about GraphRAG. But before we get started, we've known each other a long time, but I have never asked how you got into graphs. Like what drew you in the first place?
Hey, Amy. So nice of you for having me. And like, if we go directly into it, it's kind of really funny story because like I was playing online poker till I was around 25, 26 years old. And at 25 or 26, I was deciding what I want to do in life. And obviously I had no idea what I want to do, right? So my brother got me like junior developer role as an intern, basically some like a low level paid worker, right? And that's how like my journey into IT or like development started. And the funny thing is that my boss was super excited about Neo4j. He wasn't so technical, but he was super excited about Neo4j and about connections and nodes and all of that and all the cool that you can do with it. He had some fancy ideas about modeling brains with graphs and basically a lot of fancy ideas. But basically, the outcome of that was that the first thing I learned in like development was how to model Neo4j. It wasn't like Python. It wasn't anything else. It was direct Neo4j modeling. So Cypher was kind of the first language I learned. So.
Oh wow! Oh, that's a wonderful story of coming right into Cypher. And what are you working on right now? I mean, obviously the books just come out, but in general, what have you been working on the last few years?
I mean, so before LLMs were the thing, I was focusing more on graph algorithms and graph data science, which I'm sure you know. And then after LLMs became a thing, basically, I think it was something like this. I was one of the first one that got GPT-4o preview in, I want to say company, but for the most part, anybody I knew. So it gave me kind of the option to start like playing around with LLMs and testing and like kind of learning in public. And then basically this kind of experimenting turned into a full-time job because like for the last year and a half, basically what I've been doing was just kind of contributing to LLM frameworks. So I did a lot of contributions to LangChain and Llama Index, and it was all about GraphRAG. So it was kind of my journey of kind of getting to know GraphRAG and kind of sharing it with the world and getting the feedback. But what basically that was kind of the background, and then me and Oskar kind of decided, because how I see it, why you see so many agent frameworks and so many frameworks around the LLM is that kind of code is usually fairly simple, right? That is just like one LLM call, one database call. Like it doesn't take a rocket scientist to implement this. So what we kind of wanted, me and Oskar, to write a book about kind of the concepts behind GraphRAG. So it's not like...
So yeah, okay, that just made me think, okay, but why a book on GraphRAG now? Why was this need for getting the concepts out necessary, now? Because things are moving around. You could have waited to write it. You could have written about it a while ago when it first came out. So yeah, what about this moment, that you and Oskar was like?
Okay, I mean, GraphRAG is really popular at the moment, but for me, it's more about that. It's basically the last year and a half, 2 years, basically it was all about PDFs and text documents and what you can do with them using LLMs. And for the past year or so, I've been kind of saying, but we have more than text and PDFs. We have Excel tables, we have JSON files, we have relational databases, we have data lakes, we have graph databases. And basically, and don't you want to kind of think about how to kind of include that information as well, right? And then, because for me, how I see it, mostly people focus too much on the unstructured part. For some reason, PDFs are really popular, right? Everybody's got a PDF, but nobody's really, at least not until really recently, people weren't really talking about building like an agent on your database, on your API or whatever. And I feel like a lot of people are missing a lot of value by just focusing on text and text embeddings, basically.
Yeah. Yeah, I would agree with that. You had said before we hopped on the call that you had something to share with people, and I know. So if you want to share that screen with the people who are looking at it, there's two pandas hanging out, chatting with each other, and one panda says to the other, "Do you ever think perhaps there's more to data than unstructured text?" The other panda says, "You mean like structured data?" So,
Yeah.
which is quite funny. So apologize. I will include a link to the image for those that can't see, but it's explain why this resonates so well with you, and it makes me chuckle as well. But yeah, what resonates well with you on this image?
I mean, so basically, this is like anybody that you talk to. It's kind of, I feel it's like an LLM RAG developer journey, right? It's like everybody starts, okay, let's chunk a document, let's embed it, put it into a vector index, and let's do basic vector search, like this generation. And that works when you got one PDF, two PDFs, 5, maybe 10 PDFs. So like, depending on domain, it can be a lot more, right? But some like use cases, like completely, like even like 10 or like 15 documents to create inaccurate retrieval, right? Because a lot of times, also what I see is people are trying to ask questions that cannot be answered using text embeddings, right? And I kind of want to expand people's mind and say also on that front is, because you've got structured data, you can also perform structured operations on top of the data, right? So if before you can just search for relevant documents, now with structured data, what you can do, you can start counting things, right? Or aggregating or sorting things. So you can say, show me the latest news about GraphGeeks, right? And there is 0 text embeddings needed for this query, right? And I'm trying to kind of educate the people that yes, text embeddings are really awesome at what they do, but they're not meant to solve everything. And there are other solutions for other types of problems, which I'm trying to enlighten people about.
Yeah, I chuckled a little bit when you said count, but because a colleague in common, you probably remember working with Dr. Claire Sullivan. I was speaking with her the other day, and she has this phrase that if you can't count, you're not really doing data science, which is kind of funny. Like you have to be able to count stuff, right? But so one of the things before we dive into like this is a very interesting topic of multimodal, into RAG. Like, how do you get different types of data in RAG is, I think, a really fascinating area. However, before we dive into any of these really cool areas, can you describe who you intended the book for, like what kind of reader you're writing this for, and what they can expect to find in the book?
So the book is kind of intended for like a developer who has kind of built their own like chat with a PDF application, and they tested it, and then you can see kind of what is good at, what limitations, and now they want to kind of take the second step and kind of expand the toolkit for like different retrieval options, right? And this is, I feel like, where me and Oskar are trying to position ourselves. So when you want to go just beyond vector search, and that doesn't mean like kind of that GraphRAG competes with vector search or vector databases. For me, it's more like augmenting it, right? Because you still need to find information in documents, right? Everybody's got documents, and that's not going away. But what you can do, you can maybe start structuring that text, right? So there's like, people used to call that NLP. I don't know, but now everything's called AI, right? That's like one approach, but then the other approach is also we've got a bunch of databases, like user database, product database, CRMs, like sales database, whatever, like that could also be included. Like, because imagine, for example, you're building like a chatbot for management, because that's usually who wants to talk with. And like, for example, if the CEO might want to ask questions like how many new customers we got yesterday, like what's churn rate, or like some sort of, I call them like BI questions, like business intelligence. Basically, you do some sort of filtering, sorting, aggregating, right? And like the prime example is like BI. So this is like one thing, it is enhancing kind of the operations your chatbot, basically the tools provided to your chatbot can do. But it's also like what's a little bit also explored is like how to build knowledge graphs from text, right? Because that's such an interesting area and nobody has solved it yet, right? Or at least it's not like, there are like some has approximations how to kind of solve things generically, but it's not final just yet. And I feel like it's a really interesting space as well, right?
Yeah. You wrote a whole chapter on constructing knowledge graphs with LLMs, which, as you said, is I don't think anybody's figured out the best way. There's probably no one way to do it. But what kind of challenges are you looking to help people through with that chapter? What can they look forward to seeing?
Basically what I'm trying to educate people as well is that when you don't do any upfront work, results will be, will vary, right? Because like if you look at any demos of like knowledge graph construction, what they instruct the LLM is to extract nodes and relationships, and sometimes they node types, like some constraints like people organizations. But that's about it. So it leaves a lot of kind of margin for ambiguity to the LLM. It's like do whatever is that day, right? Whereas I am basically what I'm seeing is like my observations are like the more specific you can be, the better the results will be, right? So for example, we're extracting information from legal documents. So we're not really saying please extract entities and relationships from our documents. But what we're kind of prompting the LLM to do is say, okay, every contract has a start date. Please extract start dates. Every contract has parties that signed the contract. Okay, please find responding parties, and so on. So we kind of define the model upfront. So we kind of do the heavy work of actually checking what's in our data, what we want to do, and how we want to extract it. And then just basically extract information in a very constrained way from contracts so that basically the results are very consistent and accurate, right? Because you guide the LLM a lot to do what it needs to do.
So if I infer or understand correctly, you're suggesting that people create and lock down their schema before they have LLM do their extraction? Is that correct, or am I inferring a little too much?
It's correct, because this is always the question. Then, if I want to catch all the information, the relevant information, because it's like the health problem. You get 10,000 documents, and what's the relevant information, right? Who knows? And basically, what I've been thinking more or less is that you kind of have your kind of code predefined schema, like from the documents, and then there's an option for you to kind of allow LLM to extract some additional information that might be really interesting to solve a specific case, depending. So that's kind of then the option for the users as well. So that, because I understand that extracting, like knowing in advance what exactly you want to do really knows. Because if you ask managements, they'll just, I want a chatbot that does everything. So, but you have to understand, because the space is relatively new, like it's not like really mature, so experimentation and iteration is definitely going to be needed, right? Because
Yeah, and I would say iteration's more important than perfection, or it's even more important than maybe being super smart. You you iterate back and forth, but starting with a schema or a model, just definitely pares down the work the LLM has to do. There's another gentleman, CEO of Kinneviz, Weidong Yang, who talks a lot about the way he goes about constructing the knowledge graphs with LLMs is starting with a schema, but then allowing for the iteration. But he also has a concept of abstracting concepts and then figuring out what to do with the concept, which I think is kind of an interesting, I like these ideas that are middle grounds until you either figure out how your knowledge graph can be tailored to your specific business problem or how it's going to evolve. So it sounds like you're taking kind of that, middle ground of having the human in the loop, starting with a goal in mind, but iterating over it.
If you don't know what you want, how are we gonna evaluate the model or the performance? Because if you just want to do vibe coding and vibe testing, okay, but if you want to do something serious, you need some sort of hard metrics, because I see for prompt engineering, nobody really knows what they're doing, right? Because it's what do you type? Do I write a long sentence, a short sentence, or use a different word? Does an exclamation point make a difference or not? Right? Nobody knows, right? So what you do, you define evaluation data set, and that's and another thing that's really great about evaluation data sets that they kind of define the scope of your application. So we also talked the last chapter is about evaluation. So in evaluation, first you define the scope of your application, which is a really good point, right? Because it's not what are we solving everything. It's okay, we're solving specific things, and that's a good start. But then we can also then evaluate prompt engineering, right? Because what I've learned is we don't really know, and you change one of the prompt and accuracy goes down, but it's you gave it another good instruction, let's say, that should kind of theoretically increase. You didn't really thought twice about it, but it's somehow maybe use some different words, or it was a little bit ambiguous, or I don't know what. But those are then kind of the things you can pick up with LLM, with evaluation, so that basically you can actually improve knowingly, right? Because otherwise you just vibe testing. So it's fine, but yeah.
Well, but that kind of goes to the point of making things production ready, and consistency is important. Evaluation. I am really fascinated right now with the development of benchmarking, potentially monitoring, things of that nature with GraphRAG, because at the moment, you even if you measure accuracy once, that doesn't do me a lot of good 6 months from now when my data's drifted, or how do I continue to do this stuff for production. And I was really excited to see that your last chapter is on application evaluation, and so we've just been talking a little bit about that, but I apologize, I did not actually get to read the last chapter because it was last, but I was really excited about it. But what tools were you using or methodologies for your evaluation in that last chapter?
So for the evaluation, we made it slightly simple. We went with RAGAS. So we just took the 3 existing metrics: faithfulness, answer, relevancy, and I think context recall. So basically just kind of to show the ideas, because with evaluation, but how do you prepare benchmark data set if your underlying data is also changing, right? Stuff like that, right? So basically what we then propose, instead of kind of hardcore returning golden truth as a string, right? What you do is kind of return this relevant cipher statement that would return information, and then you're kind of independent of the underlying data changes, right? So that's kind of one thing. And then we showed that basically, you can measure different parts of your pipeline. So you can measure how well that is kind of fetching the data, right? Because, for example, if you're doing agentic, what you could do, you could kind of test how well tool selection is has been done, right? But you can test how well the LLM understands information from the context, because just because the information is in the context that was returned from the tool doesn't mean the LLM will give the answer that you're looking for, right? And you can do like an end-to-end evaluation. So it's not like, I would say, it's more like to get you thinking, right? To start thinking. But the book is designed to get you thinking. It's not like about specific LLM or specific library or anything like it. Like getting you think, okay, for example, we start with, okay, text embeddings, everybody knows what they are. But now here's a twist, like in the third chapter, people think that you always embed what you retrieve, right? So if you have a text chunk, you embed that same text chunk and use it in a vector index, and then return the text as well. But you don't have to do that. You can embed whatever you want, right? You could, like, what I've seen is, for example, you could generate like a summary and embed that, or you could generate potential questions about that could answer, right? Because then you would be doing like question comparison with text embeddings instead of question to documents. Right? So this is kind of to get you thinking, right? It's not like we give you like, here's a, like, I don't know how you say, like a silver bullet that solves everything. It's more like, that's not gonna happen. I'm sorry. Somebody gonna have to do the work. Yeah.
But we like silver bullets. But I will say, this is, as you were speaking, I was thinking, okay, this is and this kind of goes back to why this book now, because things are changing so quickly. But the idea is like, okay, right now at this point, as the landscape's changing, having a good conceptual framework to approach things is really important. But being loose enough to adopt different things as they move around and evolve. It also made me think, oh goodness, this is just the first of these books, Tomaz. You are going to have to write another one when things start to evolve and solidify a little bit. But I do want to ask you, before we run out of time, do you have a favorite chapter? Was there one chapter that was either just you learned a lot doing, or was just fun to write? I'm just always curious what authors enjoy doing.
For me, kind of the most interesting chapter is the one where we implemented the Microsoft's GraphRAG implementation. So basically, there's like a Microsoft GraphRAG research paper, and there's also open source repository. And what we do is we kind of replicate the graph indexing and also retrieval using Neo4j's, so that basically we show you what's happening along the way. And for me, why Microsoft GraphRAG was such an interesting paper is like you said, those little things, right? So for example, you know how usually in knowledge graph construction you extract triples. So you have subject, predicate, object. But that's a very, reductionist way of storing data, right? Because you lose a lot of information like that. I mean, most of the time, right? Yeah, you could model and do all sorts of cool stuff, but like it's really hard to do. So most of the time when you're kind of taking text, and reducing it to some information, it's just how it is. But Microsoft then said, okay, let's, instead of just extracting the triples, let's also extract descriptions. So now each entity and relationship in a graph has this like more like a free-form text attribute. And now this attribute can be stored used to store more like nuanced information, right? It's kind of harder to represent as triples. So that was kind of one very interesting idea. It's very simple, right? Just one description attribute, but it's kind of the thinking is slightly different. And then what I've also really liked about their paper is they showed that like when you do a single extraction pass on a text, so you say, okay, you have a chunk of text and you ask the LLM to extract triples from the text, let's say. The output, the extraction is never exhaustive. Like usually it's not exhaustive. So usually in practice, they had to kind of run 2 to 3 iterations over the same text to extract the entities. Because how I kind of rationalize it to myself is kind of LLMs are trained to kind of please the human. It's like, it doesn't matter it's correct, it just it looks good, right? And like for the LLM, like 15, 20 entities looks good enough, right? So it's the sufficient, right? It's not perfect, but it's sufficient. So that's kind of how I kind of rationalize. And then you kind of say it like treat it like a toddler. Like, did you extract all the information? And then, because if it was funny when you just ask it the second time and you don't make sure that there are actually some entities missing, the LLM might start hallucinating, right? Because you're asking for things and it also wants to kind of solve the test, even though it's not. So you have to ask it, are there any more entities? And if they are, let's do another extraction pass. So that was also quite interesting. So this is like the little things that you have to take into account when you're doing stuff in production, right?
Yeah. It's interesting to think about, as you were describing having to do multiple iterations, and 15 entities might be enough for the LLM. It's happy that it just reminded me of, I hate to bring everything back to graphs. No, I love to bring everything back to graphs. But it reminded me of random walks, right? Like if you have, depending on how you do your random walk, you get a different result. And if you do enough random walks, you pretty much sampling the entire, data set and just, making something walk again or test again or evaluate again. Is interesting to think about different, layers of accuracy and representation. And along that line, thinking about, LLMs and probabilistic results and graphs giving you more deterministic results, and mixing those two for, almost like a slider, for how much accuracy you need.
Nowadays, people call it neurosymbolic.
Isn't that sexy? I know. I'm really excited. Yeah, yeah.
It's basically fairly simple. I use LLMs for things it's good at, like interpreting text, writing text, and you use things that are good for storing facts, like graph databases, right? And you use the tool at what it's good at, and you don't really worry about, because I've tested it, and you don't want kind of the LLM to count, even if you kind of give, let's say, a bunch of line items or how it bullet points, and you don't want to count it because it's not so good. So basically, you just take it at face value. LLM, text, facts, like calculations, databases, right?
You're bringing it back to counting. So I love that.
Exactly.
So looking at the next, let's say 6 to 9 months, is there anything in particular you're excited about? Maybe research you've been reading or things you're testing with that we'll hear about in the future?
I mean, now I'm getting excited about MCPs, because nowadays, if you want to do anything agentic, you have to do it on your own, which is a little bit boring, right? You want things to just out of the box. So I feel like, how nowadays everybody's got their own, like every software as a service has their own API. In 6 months to 1 year, they'll have MCP servers or something. Maybe it's not the MCP server, it's a different standard, but basically these API interfaces for LLMs, right? And that's what I'm excited about, right? So you have like your Anthropic LLM, and you say, I'm going to give you option for my calendar, for like booking or like ordering food, and I don't know, whatever, and recommending movies. So these are the tools I give to you. I just click 3 buttons, and now my LLM can do all those things.
Yeah.
Like that.
Yeah, almost like I'm excited about that. I mean, enabled by that, things like catalogs. Like I want an LLM catalog. I want a, agent catalog. Like I want a catalog of agents that do certain things, and I can pick the one that works well for me. So yeah, definitely a lot of exciting things, and I'm sure we'll be in a future book, because you're just a very prolific writer. So I can definitely see that. But to remind people, the book is Essential GraphRAG. It is available now. And Tomaz, where should they look for the book?
So if you go on Neo4j books, Neo4j/books, the book should be there, and it should be sponsored, so you can get it for free today.
Awesome. We all love free stuff, and especially free books. by you and Oskar as well. So I will also include that in a link in the notes or description of this discussion, so you'll be able to find it. Tomaz is also prolific on LinkedIn, so you should be able to find him there as well if you want to follow him. And definitely, I would say definitely follow him. As I said, very prolific in this space. Tomaz, just for time, we'll have to leave it for there, but is there any final thoughts that you want to leave our listeners with?
I mean, I'll just go back to the pandas, right? Life is more than text embeddings.
Oh my goodness, that would be an amazing bumper sticker or t-shirt. So I may steal that. I'm going to steal that from you, Tomaz. Okay.
You have to send me one.
All right. Well, thank you again, and thank you everybody for listening.
Thank you.